In this video, I'm going to be showing you a few demos to introduce you to a new law of physics. For the first demo, I'm just going to lean against the door. My question for you is the door exerting a force on me? Well, clearly the door is exerting a force on me, because if it wasn't, I would simply fall over. Now, am I exerting a force on the door? Clearly, I was exerting a force on the door because I was able to open the door. So the door was exerting a force on me, and I was exerting a force on the door. Here's a demo you can do along with me. You'll need some heavy object. A heavy textbook would be ideal. So pause the video, get yourself a heavy object, and then pick up the video. So here's what you're going to do. You're going to take your textbook, or whatever the object is, and balance it on your fingers like this. When you have your object balanced on your fingertips like this, are you exerting a force on the object? You are exerting a force on the object. And how do you know? You must be exerting a force on the object, because otherwise the object would fall to the ground. Is the object exerting a force on your fingers? The object is exerting a force on your fingers. And how do you know that? You know that because you can feel the object pushing on your fingers. So your fingers are exerting a force on the object. The object is exerting a force on your fingers. Now let's say that you suddenly lift the object. When you suddenly lift the object, does the force that your fingers exerts on the object increase? Well, that force must increase, otherwise the object would just stay where it was. And when you suddenly lift the object, does the force the object exerts on your fingers increase? Well, if you try it, you can feel that the force the object exerts on your fingers increases as well. So to sum up, when you're just holding the object in place, your fingers exert a force on the object, and the object exerts a force on your fingers. When you suddenly lift the object, the force your fingers exert on the object increases, and the force the object exerts on your fingers increases. Here's a third demo. I have here a basketball and a tennis ball. I'm going to start by just dropping the tennis ball. We can see that the tennis ball bounces up to about here. Then I'll drop the basketball from about the same height. The basketball bounces higher up to about here. Now let's say I drop the basketball and the tennis ball together with the tennis ball on top of the basketball. Do you think the two balls are going to rebound to the height of the tennis ball? Will they rebound to the height of the basketball, or will they rebound to somewhere in between? So let's see. You can see what actually happened is that the basketball bounced much lower than its original height, whereas the tennis ball ended shooting way up. Okay, so what happened here? Here's what happens. When I release the basketball and the tennis ball together, what happens is that the basketball actually hits the table first, and then on the rebound, the basketball and the tennis ball have a head-on collision. In that head-on collision, the tennis ball exerts a downward force on the basketball, which suppresses the rebound of the basketball. On the other hand, the basketball exerts an upward force on the tennis ball so that the tennis ball shoots way up. Let's do that one more time. Never gets old. Now we're going to summarize the three demos that I've shown you in this video. In the first demo, I exerted a force on the door, and the door exerted a force back on me. In the second demo, your hand exerted a force on a book, and that book exerted a force back on your hand. In the third demo, a basketball exerted a force on the tennis ball, and then the tennis ball exerted a force on the basketball. I hope you're noticing a pattern here. In any interaction between objects where forces are involved, each object must exert a force on the other object. So if I push on the door must push back on me. If your hand pushes up on the book, then the book must push down on your hand. If the basketball pushes up on the tennis ball, then the tennis ball must push down on the basketball. This principle applies not just to the objects in the demos, but this principle applies anytime that two objects interact with each other. Anytime two objects interact, each object must exert a force on the other object. So let's say that we have two objects interacting here. Let's say we have object 1 and object 2, and we're going to have the objects pushing on each other. So let's say that we have these two objects here interacting with each other. One exerts a force on 2, and 2 exerts a force on 1. What can we say about the relation between the directions of those forces? Let's look back at the demos I showed you. Can you see that in each of the demos I showed you, the forces that the two objects exerted on each other were in opposite directions? I pushed the door to the right, the door pushed me to the left. Your hand pushes the book up, the book pushes your hand down. The basketball pushes the tennis ball up, the tennis ball pushes the basketball down. So when two objects interact, they exert forces on each other, and those forces must be in opposite directions. How about the strengths of the forces? Unfortunately, I wasn't able to work a demo for this into the video, but we can still kind of get the idea. In this experiment here, the book and your hand were exerting forces on each other. And remember that when your hand exerted a stronger force on the book, then the book exerted a stronger force on your hand. The reason for that is that when two objects interact, the forces that they exert on each other are always equally strong. So that's the other part of this. When two objects interact, they exert forces on each other. The forces must be in opposite directions, and the forces must be equally strong. This entire statement is known as Newton's third law of motion. There's one more thing we need to do here, which is to express this idea mathematically. To see how we're going to do that, I'm going to go into this figure here, and I'm going to draw in some force vectors. So let's say I have object 1 pushing object 2 to the right. Let's call this force 1 on 2. And if object 1 is pushing object 2 to the right, then object 2 must be pushing object 1 to the left, according to what we've said here. So this would be the force that 2 exerts on 1. So we have these two forces, the force that 1 exerts on 2 and the force that 2 exerts on 1. The forces are equally strong and in opposite directions. Now, what is the mathematical relation between two vectors which have equal magnitudes and are opposite in direction? Well, when two vectors have equal magnitudes and are opposite in direction, then one is minus the other. So to express Newton's third law of motion in mathematical form, we can say that the force 1 exerts on 2 is equal to minus the force that 2 exerts on 1. So now I have shown you Newton's third law of motion as 3 different demos, written out as a sentence, and in this very compact mathematical form. In the next video, we're going to do an example problem where we use Newton's third law of motion.